Okay, so now let's take these new values we found and substitute them back into our original equation. So we have the square root of a squared minus x squared, which we know x equals a sine theta. Now I'm going to go ahead and just distribute my exponent right now to make it a little bit easier, leaving us with a squared sine squared theta. Let's go ahead and factor out an a squared. So that would leave us with a squared times 1 minus sine squared theta, square root of. Now we know that this is a Pythagorean identity, which says that that equals cos squared theta. So let's rewrite that as a squared cos squared theta. And now we can take the square root of this guy to get rid of our radical, and we have a cos theta. Okay. So now let's go ahead and use this and put it back into our integral. So we have 4b over a integral of from 0 to pi over 2 of cos squared theta, or cos theta times our d theta was a cos theta, d theta. Well, we already know one of these a's can cancel out this guy, so we can cross him out, and then we're going to bring our other one outside the integral because remember it's a constant. So we have 4ab integral from 0 to pi over 2. Cos times cos is cosine squared theta d theta. Excuse my dog throwing his bowl around. Okay, so we're almost at a place where we can take the integral of this. So going back to our pre-cal days, we can use a half angle identity to put this into terms of something that we can integrate. So if we do that, we have 4ab sine from 0 to pi over 2, and the half angle identity would make that 1/2 1 plus cos 2 theta d theta. We can finally take the integral. We'll go ahead and get the 1/2 out here, so we'll divide by 2. So now we have 2ab times the integral of 1, it's just going to be theta, and the integral, oops, forgot an s in there, of cos 2 theta will be sine 2 theta over 2. And again, we need to make sure we keep our upper and lower bounds. This is going to be from 0 to pi over 2. Now, we know that we're going to take our bounds and subtract them, our lower from our upper, and then we can find out what this integral actually is. So we'll keep our 2ab on the side over here, and we've got, our upper from our lower, I'm sorry, and so then we have pi over 2, then sine of pi over 2 is just going to be sine of pi. And so it'll be 1/2 sine pi, which is sine of pi is 0, over 2 would be 0, so plus 0. And let's go ahead and put an extra bracket, minus 0 plus 0, because if we sub in 0 for theta, we get 0, and 0 for sine 2 theta is 0. So now we have 2ab times pi over 2. Now, we can go ahead and cross out our 2's because they're going to cancel, and we are left with ab theta. So, pi ab. Now, we can go ahead and set b equal to a, which would give, and if we look back at our original, going from the center of our ellipse out to here would give us a radius. So we can make these equal to r. So then we get pi r squared. And that is how we end up with the area of an ellipse being the same formula as a circle.